Okay, so if we're going to go ahead and go over the quantum model of the atom, I'm assuming that you've already tried to answer most of these on your own. But if you haven't and you're struggling, most of these are found. Okay, so explain the big difference between Schrodinger's orbitals and Bohr's electron models, okay, or electron orbits. Okay, so if we look in the notes and we look into Schrodinger and what he said, well, first, he used mathematical wave properties to describe the paths of the electrons, okay? But what we talk about with Bohr is Bohr talked about orbits being just circular orbits, okay? What Schrodinger said is electrons still have fixed amounts of energy, okay? So they are in orbits, orbit 1, energy level 1, orbit 2, energy level 2. But he said they don't follow exact path, okay? And so what Schrodinger did is he gave electrons wave-like properties. Okay, so if I were to go ahead and put an answer, Bohr had fixed orbits. Okay, Schrodinger did not have fixed orbits, had electrons traveling with a wave-like property. Now, don't get this confused, okay? Schrodinger did say that they had fixed amount of energies, okay, but they weren't just traveling along this circle that you would see here, okay? So Bohr's model was this blue model. Schrodinger was this red model, all right? So that's the biggest thing between Schrodinger and Bohr. Schrodinger gave them characteristics of a wave based on mathematical calculations. Okay, so moving on. Why is there uncertainty when trying to locate an electron? Well, and what principle does this describe? Well, if you continue reading your notes, okay, so up in slide 3, well, it's impossible to find an electron because one, they're moving so fast, and two, okay, you can't see them. The only way you can see them is when a photon knocks an electron off course, okay, and it raises it up to a higher energy level and it drops down. Okay, so the principle that this describes is Heisenberg's uncertainty principle. It is impossible to determine simultaneously the position and the velocity of an electron because one, it's always moving and it's moving super fast, and two, we can't see it. They're small subatomic particles. Okay, so based on what I just said, go ahead and fill in your answer. Now, I'm going to not give you guys these answers, but instead I'm going to go ahead and tell you where to find these answers. Okay, so this answer can be found on slide, I believe it's 6. Okay, so slide 6. So if I click on slide 6, the 4 probable electrons. So what does the energy level tell me? What is the sublevel, atomic orbital, and what is the spin? Okay, so that's where you're going to find the brief description of each one of these. Okay, now it says draw the shapes of the types of orbitals. Okay, so now we're going to be talking about your sublevels. Okay, and what is the shape of the orbital? And I even give them to you below. Okay, so that's going to give you the answer for question number 4. And then how many electrons can be held in each orbital? And so I want you guys using your notes, okay? Each orbital, so if I go to my orbitals, an orbital can only hold 2 electrons. So when we go to this one sphere is 1 orbital and 2 electrons can be held. Okay, well, I have 3 different orbitals here for the p sublevel, and 2 can only be held in each orbital. Okay. Now, how many orbitals do I have in my energy level? And so in the video before, okay, I've gone and talked about my atomic orbitals right here. So energy level has one sublevel, and that sublevel holds one orbital. Well, if that one orbital can hold 2 electrons, then there's 2 electrons in one energy level. Okay, so the number of orbitals that I have is going to be 1. I only have one s orbital. I have 0 p orbitals, 0 d, and 0 f. For my second energy level, I have 2 sublevels. I have 1s and I have 1p sublevel. Now it says 2s. It's just saying energy level 2. I'm saying I only have one sublevel in there, which is an s, and 1p sublevel. Okay. So you're going to have 2 orbital. Ooh. I have 2. I have 1 s sublevel. I have 1 p sublevel. I have 0 d and 0 f. So what I want you to go ahead and do is go ahead and fill in the rest. Oh, sorry, p. There's 3 orbitals in a p. Okay, so this should be 3 because remember, p has 3 orbitals. Okay, when we go to the next one, we have s, p, and d, and notice how many orbitals there are. Okay, so there is 3 sublevels. You have 1 in the s sublevel, you have 3 in the p, and then you have 5 orbitals in the d sublevel. Okay, and then you can go ahead and answer the last one. Okay, so looking at your notes, okay, how many orbitals are in each of those sublevels for energy level 4? Okay, so which orbital shown in the diagram on the left is the lowest energy level? Well, think about it. Okay, the nucleus is right here. And so this is my nucleus that I've drawn. Anything closest to the nucleus has the least amount of energy. Okay, and so increasing energy on the side. Well, which one of these energy level and sublevels, okay, has the least amount of energy? And so the orbital shown in the diagram on the left is lowest in energy. Which one? Okay, your answer should be 1s. Okay, because it's closest to the nucleus. So the energy or the orbital is s. Okay. What energy level is that orbital in? Well, it's in energy level 1, and that's what that 1 is telling me. So it's going to be energy level. So n equals 1. So what orbital shown in the diagram on the left is highest in energy level? Now, some of you guys are looking, well, it could be 6 sounds like it's the highest, but which one of these lines is the highest? Okay, and so it's going to be an electron in 4f. Okay, so your answer should be 4f. Using the diagram on the left, explain why an electron will be placed in 4s before 3d. Well, I want you guys to realize why these overlap. Okay, and so you guys got to remember electrons are moving in a wave-like property. Well, if it has least amount of energy, its wave's not going to be big. Well, as I start getting further away from the nucleus, my waves start getting a little bigger. So I'm showing you my electrons are moving. Well, once we start getting into 3, okay, they start overlapping. Okay, so the waves are getting bigger. Now, this 3 is going to be in energy level 4 and 3 because they're getting bigger. So imagine 4. As I get further away from the nucleus, its energy is way bigger. Okay, so just to understand, that's why we see energy levels overlapping, is because the electrons are actually, as they get further away, they're getting more energy. And the more energy we have, the bigger the wave's going to be. Okay, so I'm going to go ahead and get rid of those. So using the diagram on the left, explain why an electron would be placed in 4s before 3d. Well, thinking about what we just talked about the electrons, it's going to be placed in 4s because it has less energy. So the 4s sublevel has less energy than 3d. Now, that's your answer. Okay. Now, using the diagram below, determine the maximum number of electrons for each of the following. Okay. So 1s. How many electrons can be 1s? Well, it has one orbital. And remember, one orbital can only hold 2 electrons. One up arrow, one down. So your answer, your 1s sublevel, is going to be 2. Okay? Well, each one of these lines represents an orbital, and each orbital can hold 2 electrons. So if I look at any p sublevel, well, notice I have 1, 2, 3 orbitals. For all my p's, they have 3 orbitals. Well, each orbital can hold 2 electrons. So I have an up arrow, up arrow, up arrow, and they each have a down arrow, down arrow, down arrow. So if they have 3 orbitals and each orbital holds 2 electrons, any p sublevel is going to hold 6 electrons. So if I look at 3D, I have 5 orbitals, okay? And each orbital can hold 2. So go ahead and type in your answer, okay? So your answer should be 10 electrons. And I'm just going to put E's on the back so you guys understand what I'm talking about. Okay. So any F sublevel? Well, there's 7 orbitals here. So if there's 7 orbitals and each can hold 2 electrons, there's going to be 14 electrons. Now, energy level 1. Well, look at energy level 1. Look at anything that has a 1 in front of it and count up how many electrons could go in each orbital. Okay, so energy level 1 only has an S sublevel, 1s, and we know that S can hold 2, so energy level 1 can only hold 2 electrons. If we go to energy level 3, we're going to look at everything that has a 3 in front of it. Count up your orbitals. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 orbitals, and each orbital can hold 2 electrons. So the max amount of electrons it can hold is 18 electrons because I have 9 orbitals and each orbital can hold 2 electrons. Well, let's look at energy level 4. Okay. Energy level 4, I'm going to look at anything that has a 4 in front of it. Okay, so if I count up my S, my P, my D, and my F, well, I know S, P, and D already has 9 because we just did that for 3. Okay, but let's go ahead and add 7 more. Well, 9 plus 7 is going to be 16. So 16 orbitals, and each orbital can hold 2, is going to hold 32 electrons. Okay? So what I want you guys to go ahead and go on to is writing electron configurations, and that's your work for tomorrow. So go ahead and watch the video and go ahead and complete the worksheet.